Hi all, welcome to new class. Today's class is about flip-flops. So flip-flop is a sequential switching circuit whose output levels at any instant of time are dependent not only on the levels present at the input at that time but also on the prior input level conditions. It means that the sequential switching circuits have memory. So the sequential circuits are made of combinational circuit and memory elements. And one of the sequential circuit is flip-flops. And a flip-flop is known more formally as a bistable multivibrator. So it is called bistable multivibrator because it has two stable states. It can remain in either of the states indefinitely, and its state can be changed by applying the proper triggering signal. So this is the general symbol used for a flip-flop. And the flip-flop has two outputs labeled Q and Q bar. The Q output is the normal output of the flip-flop and Q bar is the inverted output. And the flip-flop have one or more inputs. The state of the flip-flop always refer to the state of the normal output Q. And the inverted output Q bar is in the opposite state. A flip-flop is said to be in high state or logic 1 or set state when Q is equal to 1. So when Q is equal to 1, a flip-flop is said to be in high state or logic state or set state. And a flip-flop is said to be in low state or logic 0 state or reset state when Q is equal to 0. So when Q is equal to 0, the flip-flop is in low state, logic 0 state or reset state, also called clear state. And the flip-flop can have one or more input, and these inputs are used to cause the flip-flop to switch back and forth between its possible output states, so called flip-flop. And there are a number of applications of flip-flops, and the flip-flops are the fundamental components of shift registers and counters. So the examples are shift registers and counters. And the term latch is used for certain flip-flops and it refers to non-clocked flip-flops because these flip-flops latch onto a 1 or 0 immediately upon receiving the input pulse called set or reset. And gated latch Gated latches are latches which respond to the inputs and latch onto a 1 or a 0 only when they are enabled. That is when the input enable. So there will be an input enable or gating signal. It is also called gating signal. So when this enable is high, the gate latches will respond. So in the absence of this enable or gating signal, the latch does not respond to the changes in its inputs. And a latch may be active high or active low. Active high input latch and active low input latch. So latches are two types, active high input latch and active low input latch. In active high input latch, the set and reset. Set and reset inputs are normally resting in low state. So normally resting in low state, and one of them will be pulsed high whenever we want to change the latch outputs. And also in active low input latch, the set and reset inputs are normally resting in high state, and one of them will be pulsed low whenever we want to change the latch outputs. And the flip-flops, there are mainly 4 types of flip-flops. SR latch, SR latch, JK latch or JK flip-flop, SR flip-flop or SR latch, JK latch or JK flip-flop, then D latch or D flip-flop, and T latch or T flip-flop. SR means set reset. Set reset flip flop. JK means Jack Kilby. And D means data or delay. And T means toggle. Toggle flip flop. Let us study about the SR latch. The simplest type of flip-flop is SR latch. It has two outputs labeled Q and Q bar and two inputs S and R. The state of the latch corresponds to the level of Q, and Q bar is the complement of that state. So the output as well as its complement are available for each flip-flop. And this is the logic symbol for the SR latch, and this is the truth table for the SR latch. And here Q0 represents the state of the flip-flop before applying the inputs. That is, Q0 means the previous output of the flip-flop. And when the set input is made high, Q becomes, the output Q becomes 1. That is set. And when the reset input is made high, then Q becomes 0. That is reset. So the output is reset when reset input is made high, and the output is set when the S input, that is set input, is made high. Hence we call it as set reset flip flop or set reset latch. And if both the inputs are made low, that is both S and R are low, then there is no change in the state of the latch. That is, the latch remains in the same state in which it was prior to the application of the inputs. And if both the inputs are made high, the output is unpredictable. Unpredictable means both Q and Q bar may be high or may be low, or any of them may be high and the other low. So this condition is described as not allowed or unpredictable or invalid or indeterminate. And the SR latch is also called RS latch or SC latch. SR or RS latch and SC. SC means set clear latch. Because resetting is also called clearing, because we clear out the one in the output by resetting it to 0. So this is about the SR latch. The NOR gate SR latch. An SR latch can be constructed using two cross-coupled NOR gates. Using two NOR gates, an active high SR latch can be constructed. And this is the logic diagram for the active high SR latch composed of two cross-coupled NOR gates. So note that here the output of each gate is connected to one of the inputs of the other gate. So let us assume that the latch is initially set. So set means Q is equal to 1 and Q bar equal to 0. So if the inputs are S equal to 0 and R equal to 0, so when S equal to 0 and R equal to 0, then the inputs to the gate G1. So here 0 and this also 0. So 0, 0 are the inputs to this NOR gate. So the NOR gate output is equal to 1 when both the inputs are low. In all other cases, the output is 0. That is, in NOR gate, when the inputs are 0, the output is 1, and in all other cases it is 0. So here when Q equal to 1 and Q bar equal to 0, and when the inputs are S equal to 0 and R equal to 0, so here 0, 0 means the output is 1, and here also 1 and 0. So this is 1 here, 1, and here S equal to 0. So 1, 0. That is, this is 0. That is, set is 0. So the output is 0. That is, when S equal to 0 and R equal to 0, the output remains unchanged. And also if Q equal to 0 and Q bar equal to 1, then if inputs S equal to 0 and R equal to 0 are applied, then what happens? So S equal to 0 and Q equal to 0. So when Q equal to 0. Here the inputs to this gate is 0, 0. That means the output is 1. That is Q bar is equal to 1. And here R is 0 and R equal to 0 and here Q bar is 1. So 0 and 1. 0 and 1 are the inputs to this gate. So the output will become 0. So that means when S equal to 0 and R equal to 0, whatever the conditions in the output, it will remain unchanged. And let us check other conditions of this set and reset inputs. So if Q equal to 1 and Q bar equal to 0 and S equal to 1 and R equal to 0 are applied. So this is next case. So when S equal to 1 and R equal to 0 are applied and the previous conditions are Q equal to 1 and Q bar equal to 0. So here Q equal to 1 and S equal to 1. So 1, 1 to this gate. So 1, 1 to this gate means Q bar equal to 0. And here R is 0, R 0 and this Q bar is 0. So here 0, 0. So 0, 0 means the output of this NOR gate. Output of this NOR gate is 1. So when S equal to 1 and R equal to 0, output is 1 and 0. That is, in this case, no change to the input. And let us check whether it changes. So if Q equal to 0 and Q bar equal to 1 initially, and this inputs, that is S equal to 1 and R equal to 0 are applied, then S equal to 1, that is S equal to 1 and Q equal to 0. So here 0 and 1. 0 and 1 to this NOR gate means the output is 0. So Q bar will become 0 here. And the inputs to this gate, that is R equal to 0. So R is 0 and this output is 0. So 0, 0 to this gate. 0, 0 to this gate means the output is 1. So Q will become 1. That is, the output is set. So the output changed to 1 and 0 here. So when the inputs are S equal to 1 and R equal to 0, the output is set. That is, output goes to the set state. Q equal to 1 and Q bar equal to 0. Let us check next condition, that is when Q equal to 1 and Q bar equal to 0 initially and S equal to 0 and R equal to 1 is applied. So the inputs are 0 and 1. So here R is equal to 1 and Q bar is 0. So 0 and 1 here. 0 and 1 means the output of this NOR gate is 0. That is, Q becomes 0. And this 0 and 0 are inputs to this NOR gate. 0, 0 means the output here is 1. So S equal to 0 and R equal to 1 means the output is reset state. That is, Q equal to 1 and Q bar equal to 0 now becomes Q equal to 0 and Q bar equal to 1. That means the output is in reset state. And if Q equal to 0 and Q bar equal to 1 initially, and S equal to 0 and R equal to 1 are applied, then here the inputs to this gate are here 1 and 1. 1 and 1 here means the output is 0 here, and that 0 and 0. 0 0 means that is here Q is equal to 0, and here 0 and 0. 0 0 means here Q bar is equal to 1. That is here also in reset state, or when the previous states are 0 and 1, there is no change, or we can say it is in the reset state when S equal to 0 and R equal to 1. And when both the inputs S equal to 1 and R equal to 1, then, and if Q equal to 1 and Q bar equal to 0 are the previous state, then when S equal to 1 and R equal to 1, then here we get 1 1. 1 1 means the output Q bar is equal to 0, and here also 0 and 1. 0 and 1 means Q equal to 0. So the outputs Q and Q bar will become 0, and which is invalid. Let us draw the timing diagram for the active high SR latch. So S and R are the inputs and Q bar are the outputs. So assume that the latch is set. So set means Q equal to 1. So this is 1, Q equal to 1 and Q bar equal to 0. And here let us assume S equal to 0 and R equal to 0. 0 0 means the output remains in the previous state, that is when assume Q equal to 1 and Q bar equal to 0. So first condition is S equal to 0 and R equal to 0. So the output will remain in the previous state, that is Q equal to 1 and Q bar equal to 0. Next assume S equal to 0 and R equal to 1. So S equal to 0 and R equal to 1 means Q will become 0 and Q bar will become 1. That is here 0 and 1. 0 and 1. 1 means here we can draw like this. And next condition, let us assume that both are 0 0. 0 0 means previous condition, that is here Q becomes 0 and Q bar becomes 1. That is 1 here. So when S and R are 0 and 0, the previous condition is obtained. That is no change in the output. And when S becomes 1 and R becomes 0, that is set condition. Set condition means output will become high. That is 1 and 0 here. So this is 1 and here 0. Then again let us assume that the output is, the inputs are 0 and 0. 0 and 0 here. Then 0 0 means the output is no change. No change means here 1 and 0 again, that is 1. So this one we can draw like this, that is high. Here also 1. Here also we can draw like this. Next, let us assume that the inputs are 0 and 1. 0 and 1 means 0 to S, that is the output will become 0 and Q bar 1, that is here. Next again let us assume that the inputs are 0 and 0. So no change, that is 0 and 1 here. Next let us assume that 1 and 0 are the inputs. So 1 means the output is set, that is 1 and 0 here. Then again 0 0 means no change, then 1 and 0 here. So in this way we can draw like this, that is here 1. So this is the timing diagram for the SR latch. Next is the NAND gate SR latch. An active low SR latch. Active low SR latch can be constructed using two cross-coupled NAND gates. So this is the logic diagram and this is the truth table of an active low SR latch. And here when S and R, that is the inputs are 0 and 0, then the output is invalid. And when S equal to 0 and R equal to 1, then the output is in the set state. And when S equal to 1 and R equal to 0, the output is in the reset state. And when both the inputs are 1, then the output is equal to the previous output, that is no change to the output. So here when 0 0 means invalid state, when set equal to 0 or when R equal to 1, then we will get the set state, and when R equal to 0 we will get the reset state. An active low NAND latch can be converted into an active high NAND latch by inserting inverters at the S and R inputs. So this is the logic diagram and this is the truth table for active high NAND SR latch. So here when both the inputs are 0, then there will be no change in the output, and when S equal to 0 and R equal to 1, then the output is reset, and when S equal to 1 and R equal to 0, the output is set, and when both the inputs are 1, then the output is invalid. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.